Hello, children. How are you all? Hope you all are fine and safe at your home. Children, in this video, we will start with our chapter 4, that is energy. Children, in everyday life, all of us do some work. We do work when we play. We do work when we go to school. We do work when we go upstairs, when we lift a heavy load, and so on. But in common language, we use the word work much casually. For example, if we push a wall, we say that work is done. While reading a book, we say that we are working, but actually, no work is done in these activities. In physics, the word work has a special meaning. Work is said to be done only when a body changes its position or moves on applying a force on it. No work is said to be done if there is no motion produced in the body even when a force acts on it. Now we can say work is said to be done if the force applied on a body moves it. If no motion takes place, no work is said to be done. For example, cyclist pedaling a cycle does work. A horse pulling a cart does work. An engine pulling a train does work. So therefore, there are many things happening around us which shows that work has done. Work is also done by a force. If the force applied on a body changes its size or shape. For example, if a boy squeezes a toothpaste tube or a gum tube or a rubber ball or a balloon, he does work in changing the shape of tube or a ball or a balloon. Similarly, a boy does work in stretching a rubber string in which size of the string increase. So, a person does no work if there is no change in position or no motion even after application of force. For example, a boy pushing a car or a heavy stone does no work if the car or stone does not move although he gets tired. A person pushing against a wall also does no work since he is not able to move the wall. Similarly, a coolie does no work while standing with a heavy box on his head as there is no motion. But the coolie does work when he raises the heavy box to his head. So children, we can conclude that there are two conditions must be fulfilled for work to be done. Number one is a force must act on the body. Without acting any force, we can't say the work has been done. Now, the second point is the force must produce change in position, that is either change in motion or produce change in size and shape of the body. Without change in any position or a size and shape, we can't say work has been done. Now we'll see factors affecting the amount of work done. Experimentally, it is found that the amount of work done by a force depends on following two factors. First one is the magnitude of the force applied, and the second one is the distance moved by the body in the direction of force. Now we will discuss the first point, that is the magnitude of the force applied. See children, work done is more if the force applied to move the body is more. For example, more work is done by us if we lift a bucket full of water from the ground floor to the first floor than if we lift an empty bucket to the same height. The reason is that we have to apply a greater force to lift the bucket full of water as compared to lift the empty bucket. Now we'll discuss the second point, that is the more work is done if the distance moved by the body in the direction of force is more. Understood? For example, more work is done by us if we lift a bucket of water from the ground floor to the second floor, then we lift the same bucket from the ground floor to the first floor. Since we can say there is two factors needed to say that the work has been done or not. First one is the magnitude of the force and the second one is distance moved by the body. Now we see the definition of work. The work done by a force on a body is equal to the product of the force applied and the distance moved by the body in the direction of force. That means work done is equal to force into distance moved in the direction of force. That is W equal to F product D. If suppose the body does not move, that means distance is equal to 0. In that case, W is equal to 0. Now we see the SI unit of work. As we all know, the SI unit of force is Newton and distance is meter. So we know W equal to F into D. So the SI unit of work is Newton meter or joule. In symbol we write capital J. The unit joule has been named after the name of the scientist James Prescott Joule. Children, hope you all have understood. Now go through your book, learn all the definition of work and factor affecting the amount of work done, and we will see on next video. Thank you.